Hello dear students, I welcome all the standard 9 students on this online classes. Already we have started chapter 5, that is pressure in fluids, and discussed about thrust and pressure and the formula for the pressure, that is equal to thrust divided by area, or thrust per unit area also we can call. Then the units of pressures, then pressure in fluids also we have discussed. And fluid means the substances that can be flow is called as fluids. And the example of fluids are liquids and gases. That means all kinds of liquids and gases are belongs to fluids. Then about pressure within a liquid also we have discussed how that one is generated. And I hope all of you are reading properly in your home, stay safely as well as utilize your time properly. It will be very good for you also. Okay. So today we will be going to discuss about and learn about manometer. It is a kind of device by the help of which we can find the pressure of a gas enclosed in a vessels. You all know that one. If any fluid is kept inside any vessels, it exerts pressure on it. That pressure, how much amount of pressure, that one we can calculate by the help of that manometer. So let us start about this. It is a device used to find the pressure of a gas enclosed in a vessel. It consists of a U-tube partially filled with mercury or any other liquid also we can take. Initially the level of the liquid is same in both the arms of the manometer, because the atmospheric pressure on the both the open arm will be equal. Okay, so that's why only the level of the liquid is same in both the arms of the manometer, because the atmosphere exerts an equal amount of pressure on both the free surfaces. You know that one atmosphere also exerts some pressure, because atmosphere is nothing but the mixture of gases. Okay, and gases, all gases are belongs to fluids, and if it is fluids then it can exert pressure also. So atmosphere also exerts an equal pressure on both the free surfaces of the liquid in the U-tube. Okay, so I am going to show you that figure which is given in your book, that is figure 5.2. about a manometer it is given, and I will be explaining about that one so that you can understand that one properly. Okay. So in order to measure the pressure of a gas enclosed in a vessel, see here it is given, left hand side that gas can be allowed or it can be connected to the vessels which is filled with gas, and that mercury is filled with that U-tube. You can see that one. Initially it was at the same level, but whenever we are allowing that gas to pass through the left hand side opening part, at that time it will exert or create a pressure. Yes. So in order to measure the pressure of a gas enclosed in a vessel, one arm of the manometer is connected to the vessel and the other end is kept open to the atmosphere. You can see that one. Left hand side that arm is connected to the vessels, and right hand side arm, that is arm C, is open. Okay, kept open to the atmosphere. So the gas exerts pressure on the left arm. Obviously that gas exerts some pressure on the left arm, that is on the mercury level inside that manometer or the U-tube. Okay, so the gas exerts pressure on the left arm, whereas the atmosphere exerts pressure on the right arm. Obviously that atmosphere exerts the pressure on the right arm, because this one is the open one only. Okay, simple one only, as you can see that one. Okay, then if the gas exerts a higher pressure, then what will happen? If that gas enclosed by vessels from the left hand side exert more pressure as compared to the air pressure or the atmospheric pressure, then what will happen? The liquid rises in the arm C. Obviously the liquid will be rises in the arm C. That's why the level of the liquid is not same after exerting the pressure by the gas. until the pressure at 2 points B and D on the same horizontal level becomes equal to the pressure exerted by the gas. So, if it is not balanced, then obviously that left hand side, that gas will be exert pressure. If it is balanced with the liquid level, right hand side air pressure, left hand side gas pressure, when they both become equal to the pressure exerted by the gas, till the level of the liquid will be rising in the right hand side arm, that is arm C. Okay? Then now we can calculate the pressure of gas, that is pressure of gas is equal to pressure of atmosphere plus pressure due to the liquid column of height h. Yes, pressure of atmosphere we can take Pa plus pressure due to liquid column of height h, that one later on we will learn. There is a formula, that is H rho g, okay, where H is equal to the difference in the level of mercury in two arms of manometer, that is height level, the difference in the height, and rho is the density of the liquid, that is mercury. Okay. So, this one is the pressure of gas, that is pressure of atmosphere plus pressure due to liquid column of height h, that is H rho g. Okay. So, this formula H rho g, later on it is given, we can see that one. Okay. So, up to this much I think all of you have understood properly. Then about depth and pressure, how that pressure is related to depth, that one we will be going to discuss. So, pressure increases as depth increases. That means if any liquid is there, if it is present in a container, on the surface of the liquid, how much amount of pressure if we will calculate, obviously it will be less if we compare the bottom part of the liquid. So, that indicates that the pressure increases as depth increases. So, this is shown in figure 5.3, and this is a very common experiment we can perform also. We can take one water bottle and we have to fill that one with water, okay, and after that 3 different holes we have to make. One will be present in the bottom part, another one will be present in the middle part, and another one, that third hole must be present at the just top part, 3 holes. After that we can easily observe that one, that means how that pressure is increasing or how it is related to depth. So, this is shown in figure 5.3, you can see that one, this one I was telling about it. Bore holes on the side of a deep can or a jar, place it under the tap and keep it full of water. First we have to fill it with water, okay. The water will sprout out much further horizontally from the hole near the bottom of the can than from that near the top. Here you can see that one, in which case the pressure will be more. Obviously, the water which is coming out from the bottom part is having more pressure as compared to the upper 2 parts, okay, upper 2 holes. If the 2 holes are made at the same level, water will sprout to equal distances from them. So, this shows that the pressure increases as the depth increases only. Very simple experiment. So, the relation between the depth and the pressure shows that the pressure is directly proportional to the depth, okay, that is pressure is directly proportional to depth, or also we can write that one as pressure divided by depth is equal to always constant, okay. So, about this one I think all of you have understood, simple one about manometer and how that pressure is related to depth, that one we have already discussed, and I hope all of you have understood that one. Again you must go through your book so that you can understand more properly, and it will remain in your brain for a long period of time also, okay. So, this much only. Thank you.